Hi, today's lesson is going to be on inverse functions, and I think you're going to like these because they are very simple and very straightforward. So the first thing I want you to see is that we are changing the input values with the output values. So in an inverse relation, it interchanges the input and output of the original relation. This sounds very mathy. What you need to know is that it changes the domain and range. In other words, you are just flipping x and y. Nothing more complicated than that. So if this is your original relationship right here, x is 0, 1, 2, 3, and 4. Y is 6, 4, 2, 0, and negative 2. To find the inverse, you switch x and y. It is not tough. So given a table, it looks just like this right here. 0, 6 becomes 6, 0. 1, 4 becomes 4, 0. The graph of an inverse relation is a reflection of the original relation. It reflects in the line y equals x. That's this line right here. So the graph reflects around that. So what you would have to do is fold your paper on that diagonal, and that'll be the reflection. Tomorrow we're going to do our finger painting activity with the reflections. All right, so moving on, now that I've scrolled my page down, I do want you to note this. Excuse me. That the original relation and the inverse relation are both functions. So, you know, to be a function, that's for whatever the graph is. Say we had something like this. You can draw that imaginary vertical line through it, and if it crosses only once, then it is a function. So what this is saying is, if the original graph is a function and the new one is a function, then the two are called inverse functions. If one of them is not a function, then they're just called inverse relations. It's kind of a technical point, but you need to know it. It will probably crop up somewhere where you don't expect it. The cool thing about this is you can tell from the graph, and I want to show you this. So we have what's called the vertical line test. And like I said, if you could draw that vertical line through the graph and it crosses only once, then it's a function. Well, for instance, if I were to have the graph y equals x squared or something roughly like that. So does this pass the vertical line test? Drop an imaginary vertical line, it crosses it once. So it does pass that. To see if the inverse is a function, now this is for the inverse, and I'll write this right down here on the notes for you. We're going to do something called the horizontal line test. Works just like the vertical, except we use a horizontal line. So if I do this horizontal line, it crosses it here and here. Therefore, that means the inverse is not a function. So it's an inverse relation, not a function. So let me show you another graph. If I had something that looks like a cubic like this, okay, so let's check this graph, a function, crosses it once, so that one is. To check the inverse, do a horizontal line. That crosses it once, so that means it is an inverse function, or one-to-one. This is some fun algebra stuff. I'm sure you're going to love it. You can tell if f and g are inverses of each other algebraically. And you go back and use that composition or substitution that we just finished going over. So you would find f of g of x, and that has to equal x, and then g of f of x, and that equals x. So you go both ways, and if they both equal x, then they are inverses. So if you want to pause the video and go through this algebra, that'd be awesome. All right, this talks again about the vertical line test and the horizontal line test. You've got some better graphs you can watch here. This right here is kind of cool. This one right here is the one I just showed you, and the one on the side is its inverse. If we were to fold this diagonally like that, you can see how we'd get that graph. So I think that's kind of cool. Okay, now for the fun part. This is what I like. I think you're going to like this part. If I ask you to find an inverse, it's super simple to do. So we'll say find, and we write the inverse like f to the negative 1 of x. That would be the inverse. So to find the inverse, follow these 3 steps. I want you to put it in y equals form. Switch x and y, then solve for y. So let me show you how easy this is. I'm going to do the first example real quick right here. So we have f of x equals negative 3x plus 1. I want to find f inverse of x. So to do that, the first thing I do is put it in y equals form. So it's y equals negative 3x plus 1. My next step says switch x's and y's. So wherever I have a y, I'm going to put an x. Wherever I have an x, I put a y. Don't do anything else, just switch x's and y's. Now the third step says solve for y. Well, here's my y right here. That's what I want to solve for. So I'm going to subtract 1 from both sides. Gives me x minus 1 equals negative 3y. I'm going to divide by 3. So x minus 1 over negative 3 equals f inverse of x. And you're done. That's all there is to it. So let's do the next one. Let's do number 2. F of x equals 1/2 x minus 1/2. All right, I want to put it in y equals form. So I've done that. My next step says to switch x and y. So now I have x times 1/2 y minus 1/2. Notice I didn't switch anything else. No, I want to solve for y, so I want to solve for this. So I'm going to add 1/2 to both sides. So x plus 1/2 equals 1/2 y. To get rid of that 1/2 times y, I'm going to multiply it by its reciprocal. I'm going to do it to both sides. So 2x plus 1 equals y, because 2 times x is 2x, and 2 times 1/2 is 1. So now that I've got it in y, remember, this is actually the inverse, so I want to be sure I write it as the inverse of x equals 2x plus 1. There you go. That's all there is to it.